A block of mass m hangs from a vertical spring of a spring constant k. If it is displaced from its equilibrium position, find the time period of oscillations. Dear student, if this is the natural length of the spring, if we suspend a block slowly, then it will come in equilibrium position. Let us assume in equilibrium position, the extension in the spring is y and spring constant is k. This is mg and this is ky. K is spring constant. So we can write equation mg equal to ky. This is equation 1. Now, if we release the particle suddenly, then what will happen? This situation will come. Let us assume elongation in the spring is x till the particle reaches to the extreme position. Now we are applying work energy theorem. Work done by gravity plus work done by spring equal to change in kinetic energy. Dear student, what is work done by gravity? Force of gravity is acting downward. Elongation in the spring is x, so work done by gravity is how much? This is mgx. This is positive, okay? And since spring force is acting in upward direction, elongation is in downward direction, so elongation and spring force is in opposite direction. Force is variable, so work done by spring is minus half kx square, okay? And initial velocity was 0, final velocity is also 0 because block has reached to the extreme position. So dear student, what is the equation? mgx minus half kx square equal to 0 minus 0. This xx will get cancelled. So x will be equal to 2mg upon k. So now you can see what is amplitude. Amplitude here in this case is mg upon k. Because what is definition of amplitude? Maximum displacement of the particle from mean position is known as amplitude, okay? For this spring, what is time period? Time period is 2 pi under root m upon k. This is a very good question. Here one should know the importance of the phase, okay? Consider a particle moving in simple harmonic motion according to the equation x equal to 2 cos 50 pi t plus tan inverse 0.75, okay? Where x is in centimeter and t in second. The motion is started at t equal to 0. When does the particle come to rest? For the first time. When does the acceleration have its maximum magnitude? For the first time. When does the particle come to rest? For the second time, okay? So dear student, here we need to find maximum first time maximum velocity, maximum acceleration, all these things we have to find. Very simple question. Now see, x equal to 2 cos. If you have the knowledge of the phase relation, the question is very simple. 50 pi t. This is theta equal to itna. So tan theta equal to 75 means how much? 3 by 4. Okay. So theta is how much? 37 degree. This is initial phase. So dear student, now if you use the phasor relation concept, the initial phase of the particle is here and particle moving in this direction. How? You know If you differentiate the equation dx upon dt and if you put t equal to 0, the velocity will come negative. Negative means what? The particle is coming in minus x direction, okay? And this is initial phase, this is how much? 37 degree, okay? This is initial phase, this is how much? 37 degree, okay? So dear student, what we need to find? Now see here. When does the particle come to rest for the first time? And when does the acceleration has its maximum magnitude for the first time? This is same thing because acceleration remains maximum at the extreme position. Okay, and particle comes to rest at the extreme position. And when does the particle come to rest for the second time? Okay, see here. When this particle will reach here, then it will be the mean position, velocity will be maximum. When the particle will reach here, this will be the extreme position. Here acceleration will be maximum and velocity will be minimum. Okay, so very simple. For reaching to this position, this angle is 53 degree and this angle is how much? 90 degree. Now question is very simple. The particle has to travel angle how much? 90 degree plus 53 degree. This is the angle which the particle has to travel. Now, if you want to determine the time and at this position, acceleration will become maximum and its value will be equal to omega square a. What is omega? In this question, dear student, omega is what? Omega equal to 50 pi. Okay. Now see, a in the question is how much? This is 2. Now problem has become very simple. In traveling angle 360 degree, time taken is how much t? In traveling angle 1 degree, time taken is equal to 3 upon 3 t upon 360 degree. In traveling angle equal to how much? 143 degree. The time is t upon 360 into 143. This is the time. And what is t? Time period is how much in this question? Time period is 2 pi upon omega. Omega is what? 50 pi. So if you cancel 2 pi 50 pi, this will become 1 upon 25 second. So dear student, time period is 1 upon 25 second. So hope you understood the concept and problem is solved. Now look at this question. This is also very good question. Time period of a particle executing SHM is 8 seconds. At t equal to 0, it is at the mean position. The ratio of the distance covered by the particle in the first and to the second is okay. What is being asked? The particle is starting the journey from the mean position. This is t equal to 0, mean position. When the particle starts journey from the mean position, the equation we use equal to x equal to a sine omega t. Okay. Now, dear student, in the first second distance table is this. We can write x1 equal to a sine omega. Okay. This is the distance table in the first second. And time period is given how much? 8 seconds. So omega equal to 2 pi upon 8. This is equal to pi upon 4. So this is how much? This is a sine pi by 4 and sine pi by 4 is sine 45 degree. This is a upon root 2. So this is x1. Now dear, this is the distance traveled from t equal to 0 to t equal to 1 second. Now let us assume distance traveled from t equal to 0 to t equal to 2 seconds. This is very easy. Let us assume this is x2. So x2 is how much? A sine omega into 2. So dear student, this will give us a sine omega. Omega value is pi by 4. So this is equal to a. Now distance traveled between t equal to 1 second and t equal to 2 seconds. This is how much? This is a minus a upon root 2. Okay. So in the question, what is being asked? Ratio. So ratio is what? x1 upon x2 minus x1. This is the ratio. This is how much? A upon root 2. And this is what? A minus A upon root 2. After solving this, we get A upon root 2. This is A root 2 minus 1 upon root 2. This root 2 will get cancelled. A will get cancelled. So ratio will come 1 upon root 2 minus 1. So this is the answer. This is the distance table in t equal to 0 to t equal to 1 and t equal to 1 to t equal to 2 second. Okay, this is the ratio of the distance table by the particle in SHM. Okay. The time taken by a particle performing SHM to pass from point A to B where its velocities are same is 2 seconds. After another 2 seconds, it returns to B. Find the time period of oscillation in second. Dear student, what is definition of time period? Time period is the time taken by particle in doing one oscillation, complete one oscillation. Okay, like particle is moving from Q, then it will come from Q to P, then P to Q. Okay, that is the time period. Okay, so dear student, since kinetic energy at point A and point B is same, means its position from mean position is also same, because what is kinetic energy? Kinetic energy of the particle is written as half k. K is SHM constant, A is amplitude, A square minus x square. So x is same, means its distance from O mean position is same at B and A. Okay, dear student, the time taken by particle performing SHM to pass from point A to B, see here, A to B is time 2 seconds, means B to A will also be 2 seconds. Now, after another 2 seconds, it returned to B from here to here. This is 2 seconds. Then definitely from here to here, this will also be 2 seconds. Why? Because position of A, B and position of A is identical from with respect to O. So time taken by particle in moving from B to P and P to B is 2 seconds. Okay. Then time taken by particle in moving from A to Q and Q to A is 2 seconds. So this is 2 seconds, this is 2 seconds, this is 2 seconds, this is 2 seconds. So dear student, this complete system makes time period that is equal to 8 seconds. Because what is definition of time period? Time period is defined as time taken by particle in one complete oscillation. In one complete oscillation is time period. Okay. A body perform SHM along the straight line ABCDE with C as the midpoint of A. Its kinetic energy at B and D are each 1/4 of its maximum value. If A equal to 2R, find BD. Dear student, in the question, what is given? ABCD is a straight line with C as midpoint. And this A is given 2R. Means what? This distance is R. Because C is midpoint, this is also R. Now, if A equal to 2R, find BD. We have to determine BD. Dear student, in this question, we have to determine BD. What is BD? And what is given? Kinetic energy at B and D is same. Means the position, suppose this is Y and this is also Y. Or this is X, this is also X. Okay. Half K A square minus X square. This is B and D are located at the same position with respect to C, because kinetic energy at B and D is same. Kinetic energy at B can be written with respect to mean position half K A square minus X square, and this is equal to how much? 1/4 of the maximum value. Maximum value is how much? Half K square. If you solve this equation, you will get half K will get cancelled. So A square minus X square will be equal to how much? A square upon 4. So A square minus A square upon 4 equal to X square. 3/4 A square equal to X square. X equal to how much? Plus minus root 3 upon 2A. This is the value of X. Okay. So we have determined X, and what is BD? BD equal to 2X. So this is equal to how much? This is root 3 A. A means what? A is amplitude, that is R. So dear student, BD is equal to how much? This is R root 3. BD in our problem is R root 3. Okay. A plank with a small block on top of it is undergoing vertical SHM. Its period is 2 seconds. The minimum amplitude at which the block will separate from the plank is. Dear student, the block will separate from the plank when normal reaction exerted by the plank will become 0. Okay. In case of SHM, you everyone knows that direction of acceleration always remains towards equilibrium position. Okay. So in case of SHM, the block will leave the contact at the extreme position upside. Okay. In case of lift, it leaves the contact at the downside. Okay. Now, dear student, look the motion of the planks. During upward motion, what will happen? During upward motion, during upward motion, you know what will happen? The acceleration will act in SHM in downward direction. So the pseudo force will act in upward direction. At the extreme position, this will be equal to m omega square a. And m, if m is the mass of the body, this is mg, and this is the normal reaction. So when the block is moving in upside, the equation is how much? N plus m omega square a equal to mg. And when n becomes 0, block will leave the contact. So situation will come m omega square a equal to mg. So mm will get cancelled. Okay. So at the amplitude a equal to g upon omega square, b block will leave the contact with respect to plank. In this situation, block will leave the contact with respect to plank. Okay. A particle executes SHM on a straight line path. The amplitude of oscillation is 2 centimeter when the displacement of the particle from the mean position is 1 centimeter. The numerical value of magnitude of acceleration is equal to the numerical value of magnitude of velocity. Find frequency of SHM. Here, student, what is given in the question? Amplitude is given 2 centimeter. And what else is given? When displacement of mean position is 1 centimeter. Numerical value of magnitude of acceleration, this is equal to how much? Omega square x is equal to numerical value of magnitude of velocity. This is what? Omega root a square minus x square. We can solve this equation. X equal to what? 1 centimeter. So substitute the value omega square into 1 equal to omega root a is what? 2 means 4 minus x is what? X is 1. 1 square means 1. This is omega root 3. This is omega square. So omega will get cancelled. So dear student, omega is how much? Root 3. And what is omega? Omega equal to 2 pi upon t. So in this question, t is how much? 2 pi upon root 3. And t equal to what? F. So frequency is how much? Root 3 upon 2 pi. This is the answer. This is the answer to the question. Okay. Cycle per second or hertz. Speed v of a particle moving along a straight line when it is at a distance x from a fixed point on the line is given by v square equal to 108 minus 9x square. All quantities are in SI units. Then find magnitude of acceleration at a distance 3 centimeter from the fixed point. Yes, student, we know in SHM relation between velocity and displacement, we can write v equal to omega root a square minus x square. We can compare this equation. Okay. Now see. We have to find magnitude of acceleration at a distance 3 centimeter. What is acceleration? Omega magnitude means omega square x means we need omega. Okay. So to calculate omega, we know the equation V equal to omega root a square minus x square. If we make the square, V square equal to omega square a square minus x square. So dear student, this equation can be converted like this. V square equal to, take 9 LCM common, 1 and 2 minus x square. If we compare these two equations, we are getting omega square equal to 9 means omega equal to 3. Okay, per second. And dear student, amplitude equal to what? A square equal to 12. Amplitude is not required because acceleration requires what? Acceleration magnitude equal to a square x. So omega equal to square 9 and x is given how much? 3 centimeter. So this is 27 centimeter per second square. This is magnitude of acceleration. Okay. This is magnitude of acceleration in this question. This is magnitude of acceleration in this question. This is very good question in SHM. The figure show a graph between velocity and displacement from mean position of particle performing SHM. Here we have to determine whether time period of the particle is 1.5 second or not. The maximum acceleration will be 40 centimeter per second square or not. The velocity of particle is 2 root 21 centimeter per second when it is at distance 1 centimeter from the mean position, and none of these. Okay, all these things we will calculate here. Okay, how? The graph shown is between velocity and displacement. We know the in SHM the graph between velocity and displacement remains elliptical, ellipse. This extreme position is a omega, where a is amplitude, and this extreme position is a. So in this question, what is given? A omega equal to 10, and what is given? A equal to 2.5. If we divide these two equations, we get omega equal to 4, 10 upon 2.4. If omega is there, A is there, we can calculate now rest of the things. Time period. Now, dear student, for part A, time period equal to 2 pi upon omega. This is pi by 2. This is pi is 3.14. This is 1.5 second, means time period value is correct. Okay, so this is correct option. The maximum acceleration is how much? Maximum acceleration in SHM is omega square A. Omega is what? 2 pi upon t. Okay, omega here is how much? 4, means 16. A is how much? 2.5. This is how much? 40 centimeter per second square. This is also correct answer. So this is also correct. The velocity of particle is 2 root 21 centimeter per second when it is at distance 1 centimeter. This also we can find. V equal to omega. Omega is 4. In this question, amplitude is 2.5 square, means 6.25. V equal to omega root a square minus x square. X square means 1 k square, means this is how much? 4 root 5.25. 5.25 what? This is 21 upon 4. So 2 root 21. We have not done big miracle. We have simply adjusted the figure. What we have done? We have simply adjusted the figure. Okay, dear student, this you also to do. So this option C is also correct. Okay. So in this question, all the 3 options are correct. For a particle executing SHM, x equal to displacement from mean position, v equal to velocity at any instant, and a equal to acceleration at any instant, then option A, Vx graph is a circle. Option B, Vx graph is an ellipse. Option C, X graph is a straight line. Option D, AV graph is an ellipse. Let's see. We will see the equation of SHM and then we will see all these things. Okay. Dear student, if the particle travels from mean position, displacement can be written as x equal to a sine omega t. And velocity is what? Dx upon dt. This is a omega cos omega t. And what is acceleration? Dv upon dt. This is minus omega square a sine omega t. Now, if we start comparing, how? Let's see. From equation 1 and 2, we can write x square upon a square plus v square upon a square omega square. This will give 1 because sine square omega t plus cos square omega t equal to 1. So graph of x and v will be ellipse, okay, like this. This is v and this is x. This will be a and this will be a omega, okay. And graph between a and x. Dear student, acceleration equal to minus omega square x. So graph between acceleration and displacement is straight line having negative slope equal to omega square, okay. So this ax is graph is a straight line, vx graph is ellipse. And what about av? If you write this equation, make the square of the equation number 2 and 3, you will get v square upon a square omega square plus a square upon omega 4 a square. We know sin square omega t plus cos square omega t 1. So this graph is again ellipse, okay. This is acceleration and this is velocity. The maximum value of acceleration is omega square a. Maximum value of velocity is a omega, okay. This graph is ellipse. This graph is a straight line. This graph is again ellipse. So dear student, in this case, Vx graph is an ellipse, X graph is a straight line, AV graph is an ellipse. So option B, C and D are correct option. Option B, C and D are correct option, okay.